Hello, everybody, and welcome to the next lecture. Okay, hold on a second while I get this PowerPoint started. Okay, so this lecture is the Earth's energy budget. What is the Earth's energy budget? We are not talking about money. We're talking about the Earth as a system and how the Earth uses the energy from the sun as it flows in and out of the Earth system. So remember that the Earth is one large system. That's very important to remember that first thing right there. It's made up of many other smaller systems, and they may be large as well, but it's one big system made up of other systems. So what happens is we get absorption, reflection, and the greenhouse effect that kind of affects the Earth's energy budget. And essentially what we're going to be thinking about here is ultraviolet radiation, the sun's energy, and how the Earth uses that energy and cycles it. Okay, so here's a really, really good little picture of the Earth's energy budget. So we've got the sun, it emits solar UV radiation, it powers the climate system, as it says there. But what's happening is the sun's energy is going down to the earth. It goes in all sorts of different directions, but we just happen to be in a good line of fire for it, essentially. So what's going on is we get some sun's energy. It goes down, it strikes the atmosphere. Some of it gets reflected by clouds in the atmosphere or other reflective materials in the atmosphere. So right here it says some solar radiation is reflected by the earth in the atmosphere. This is the atmosphere one, and then here the sun's going to go down. It's going to hit certain areas like ice caps or lighter areas and get reflected. And then we've got another line of radiation, UV radiation from the sun, and it's going to be absorbed. So about half of the solar radiation is absorbed by the Earth's surface and warms it. So what happens to the other half? It either gets reflected by the Earth, like ice caps in lighter areas, and gets reflected by clouds in lighter areas in the atmosphere. And then also what's going to happen is it's going to heat up areas of the Earth, and we're going to get infrared radiation being emitted from the Earth's surface. So what's going to happen then is that infrared radiation is going to go out into the atmosphere. It's either going to be trapped by greenhouse gases and pushed back down into the Earth's system, or it's going to be able to go just straight through. Not a lot of that infrared radiation is going to be reflected back into space as energy. It's going to stay in this atmospheric system and kind of warm up all of the other systems. One thing that we're going to talk about is the greenhouse effect. That's up here in the corner. So what's going on is some of the infrared radiation passes through the atmosphere, but most of it is absorbed and re-emitted in all directions by greenhouse gases. So the greenhouse gases are molecules inside the atmosphere they have good significant heat. So they're able to hold heat better than other molecules. So the clouds also do that, but that's mainly because clouds have a lot of H2O in them, and H2O has good specific heat. I said significant heat, I meant specific heat. So the effect of the greenhouse gases is to warm the Earth's surface and the lower atmosphere, the troposphere. It also gets reintegrated through the top of the atmosphere and comes back down or shoots out into space. So there's a lot of energy going on here just from one point, the sun. We get all of our solar radiation from the sun, and it pretty much powers every system on the Earth. So here's some extra information if you have any questions about solar radiation, climate change, any sort of climate systems. Here's all the information right here that you're probably ever going to need. NASA right here is a wonderful site. It's got all sorts of stuff, not just on climate. It's got all sorts of stuff on science. So check that out if you're interested. Okay, here's just another good example of the Earth's energy budget, but we have some numbers here so you can quantify it a little bit. So we get all of the incoming solar energy. It goes down, it's absorbed by the land, about 50%. It says 51%. and the other 49% is either reflected by the atmosphere, reflected by clouds, or reflected by the Earth's surface. So the atmosphere is going to absorb, this is infrared radiation here. It's going to absorb the infrared radiation coming off of the surface, and it's also going to absorb certain solar energies that mix in with the greenhouse gases in the atmosphere. So only about 6% of infrared radiation is radiated into space directly from Earth. 64% of that solar radiation, or that infrared radiation, is radiated to space from clouds and the atmosphere. So there's this large system going on here that's always cyclical. It kind of goes like this too. So you can think of it in a way like this, where it's just kind of continuously keeping this warm, nice climate for the Earth so that we don't die. Okay, so we're going to talk about absorption because that's one of the most important parts of keeping energy in our Earth system. So things that affect absorption are the angle of the sun. So if it's a higher angle, so the sunlight is coming pretty much directly towards the Earth, it's going to absorb better. If it's a low angle, like, we're going to talk like this kind of, then it's going to reflect off of the surface easier. And you can just think about an angle of anything. If you have a lower angle, like if you shoot a bullet and you have a low angle and it hits a surface like this, it's going to go very low. The trajectory is going to make it so that the chance of that bullet reflecting or refracting off the surface is much higher than if you're just coming at it straight like that. So that's the same thing with solar waves and solar energy. The angle of the sun has a lot to do with absorption and reflection. So higher angle, more absorption; lower angle, more reflection. So rough and smooth surfaces, we can use that bullet analogy again. If you have a rough surface, many different things, in the way, that bullet's going to come. It's going to hit one of those rough surfaces. It's going to be absorbed by that surface. If you have a smooth surface, there's going to be a higher chance of reflection or refraction. So that's the same thing with solar energy. Rough surfaces absorb solar energy better than smooth surfaces, and that's the key takeaway there. And so dark and light. We all know if you put on a dark shirt in the summer, it gets hot a lot faster than a white shirt, and that's because of reflection and absorption. Dark surfaces absorb a lot better than light surfaces. So what is a light surface? Let's think. The polar ice caps are a light surface. So when we were talking about positive feedback loops earlier, we talked about a cooling process where if you have more ice caps, you're going to have more light surfaces, you're going to get more reflection of the sun's energies, there's going to be less energy input into the Earth as a system as a whole, so you're going to get a colder environment. That colder environment is going to make it so that we have more ice caps, more light surfaces, more reflection, an even more colder environment. So it goes the other way. If you have less ice caps, you're going to have more dark surfaces, less reflection, more absorption, a hotter environment. It's going to come back over here so that you have less ice caps, more dark surfaces, more absorption, less reflection, warmer environment, and that's the trend that we're going on now. So that's just an important thing to know about the Earth's energy in the system, because it's very simple and a lot of people don't understand the science behind it. So that's just something to know, so you can school your friends on that. So the opposite of absorption is reflection, and we covered that. Okay, so here's that positive feedback loop, and this is from one of the climate change articles that I put in the additional information folder, so you can go to the site and look at this. But this is essentially what's happening with our Arctic ice. We're getting rising temperatures, Arctic sea ice melts, less reflection, more absorption, you're going to get higher temperatures, and so forth. So that's just a positive feedback loop, and it's kind of the trend that we're going on in the Earth right now, and that's why people are so concerned. It is not fake. Okay, so the greenhouse effect. The greenhouse effect is real. If anybody tells you that the greenhouse effect is not real, then they just do not know anything about science. It happens on all of the planets with atmospheres. So Venus actually has a very, very intense greenhouse effect. There are no humans on Venus, but they have a lot of greenhouse gases in the greenhouse area of their atmosphere. So it's a very, very hot system. So what we talk about with the greenhouse effect is it does occur naturally. We'll go to this next slide here. It occurs naturally. Most things that humans do also occurs naturally with the Earth as a system. But so what's going on here is we've got natural CO2, natural methane, natural nitrogen oxide, and CH4 in the atmosphere. This is just from living materials. And every time you breathe, you're inputting CO2 into the atmosphere. Every time a cow farts, it's inputting methane into the atmosphere. So that's natural greenhouse effects. What we're worried about here is human-enhanced greenhouse effects. So what's going on is in the atmosphere here, we've got these greenhouse gases. This is a big one, CO2. The only reason it's a big one is because we produce so much of it. It's not actually a very strong greenhouse gas. The only thing is that we produce so much of it that it becomes a strong greenhouse gas. There are other things that it does. It integrates with water molecules and creates acidic environments in the ocean or acid rain, all sorts of things like that, but we'll get into that a little later. So what's going on here with the greenhouse effect? Some solar radiation is reflected by the Earth in the atmosphere, and then it goes over here, and that infrared radiation is emitted by the Earth's surface. It gets stuck, trapped in this atmospheric greenhouse effect here, and so it's absorbed by the greenhouse gases and re-emitted in all directions by the atmosphere. So what's going on is all this heat energy is getting stuck in the atmosphere, and it's coming back and being reabsorbed into the Earth's surface, warming everything on the Earth. So the Earth as a system, small changes affect things very, very greatly. So what we're worried about is the human-enhanced greenhouse effect. We're noticing we've got a positive feedback loop because of that. And remember, positive does not mean that it's a good thing. It creates instability within systems. And so here's our last slide. This is something that you guys are probably going to want to look at in more depth, but it's just a list of the main greenhouse gases here. We've got carbon dioxide. 82% of our emissions are carbon dioxide. It's natural, but it's also artificially produced. We have methane, which is CH4, nitrous oxide, and fluorinated gases. So those are CFCs or HCFCs. Those are like coolants, refrigerants. We stopped being able to produce refrigerants in about 1960 because we realized the effect that it was having on the atmosphere. So we have known about this for a long time and haven't really done a whole lot about it. So here is just some quantification of these greenhouse gases here. So this is carbon dioxide, CO2. Before the Industrial Revolution, there were 278,000 parts per billion in volume in the atmosphere. So in 1994, it's even higher now, there were 358,000 parts per billion volume. So there is a human factor there. And the Industrial Revolution is when we started outputting carbon dioxide. So it's not very interesting or not very crazy to see that happening. So global warming potential is just one. Its effect on the atmosphere isn't really all that much. The only problem is, if you look at all these other numbers, 358,000 is much, much more than 1,700 or 311. But if you notice, every single one of these, after the Industrial Revolution, the concentration has increased. So the greenhouse gases have increased since the Industrial Revolution. We have seen an increase in greenhouse gas effects on the Earth. We've seen an increase in temperature. The last 10 years have been the hottest recorded temperatures in the history of recorded Earth. So there is something going on there. This GWP is what people are worried about. So CFCs are very dangerous because their GWP is extremely high. We're looking at, the effect is 7,100 or 1,400 just for using these refrigerants. So it's just something to think about. But that's all you need for this quiz. So if you have any questions, like always, go ahead, let me know, text, call, Teams, whatever you need, let me know. and go ahead and look at those other videos.